Hello and welcome to the second edition of Data Talks. Today we've got a very exciting data set that we're going to introduce you to. It's tweets by our favorite presidents. So today I'm going to be joined by Amadeus and Mo. You guys know already me. So I do data science teaching in San Francisco and I work at an AI startup. So why don't you guys introduce yourselves?
Okay, I'll start. So I'm Amadeus. I'm a data scientist from Berlin. My background is actually in neuroscience, so did some research on how decisions are made in the brain and how you can use machine learning and computational modeling to predict these things and which function is in the brain. And yeah, now I'm working in Berlin as a data scientist in an e-commerce startup, and we're basically building machine learning APIs to make things easier for merchants that manage e-commerce shops.
Cool.
Cool, yeah. Hi, I'm Mo. I was actually a student of Nate's at the General Assembly data science course that he taught, so this is a good testament to his work. My background is in bioengineering, and I did some work with like medical imaging and data processing, and that sort of is turned into data science and computer vision, where I'm out in the Netherlands at the University of Twente getting my master's degree in computer vision, and hopefully applying it to sort of data science and medical imaging type applications, most likely.
Yeah. So we are doing this sort of cross oceans, if one can say so. So bear with the latency. Okay. So with no further ado, let's dive into a data set. So the data set we have here with us today is going to be, here, let me pull this up for you, is going to be tweets. So we got a lot of stuff to cover. So I guess the first thing that we wanted to talk about a little bit was our experience with sort of choosing the tool that we were going to use to present this to you guys. So I don't know if you guys have any sort of comments on this. We started off with using something called Jupyter Lab, which is new and in beta.
Well, I mean, I don't have that much to say. Basically, we tried it out for the first time because it's a really cool tool, obviously, and it's really exciting to use. But we had some trouble setting it up. So personally, I had some trouble syncing it in Google Drive and getting access. And like every couple of minutes, I got thrown out and it didn't sync properly. I would say 50% of it was probably my fault, but 50% might not be my fault. So it was still a bit complicated to use, but yeah, it's really exciting for the future. This tool, I think, must be very useful.
Yeah, I mean, we kind of worked on it in 2 sessions before this, so it was working for me perfectly during the first session that we were working on it. And when it was working, it was awesome. It was like Google Drive, but for code and to be responsive. I could work with Nate pretty easily. But then second session, I had sort of the same issues as Amadeus, where everything was breaking for reasons I wasn't totally sure, and kind of putting out fires just to get the software to run. So hopefully some of that stuff gets fixed, because when it was working, it was pretty awesome.
Yeah, it's been hard to find like a good sort of software for actual like real-time collaboration with fellow data scientists. So hopefully they get it fixed. But so we're using Colab this time, and I'll go ahead and sort of share a link within the description of the video below. But it's been pretty useful. There's some things that have been hard to sort of get set up, but no need to go into the details here. Let's sort of just dive into the data. So Amadeus, do you want to sort of take it away?
Sure. So yeah, the data set is tweets from Donald Trump, from Barack Obama, and from Hillary Clinton. And we just wanted to basically check out what we can find out, any interesting data just based on the tweets. And so we got the data partially from Kaggle. So there was just someone posted a data set of historical data that went back until 2008, I think. And but it wasn't the very recent tweets. So from the last year, there were very few tweets in this data set. So we also used the Twitter API to get some more recent data. And there's a Python library, TweePy, it's called. It's very easy to set up. You just have to enter your credentials, and then it's easy to get some tweets. But unfortunately, like there's a limit. I think it was the last 3,000 tweets or so that you can get. So anything earlier than that, you can't get via the API. So we just combined this data together with the historical data that we get from Kaggle. And yeah, you can see there what data we got in the end. So it's just all the text from the tweets, author information, which is just one of 3 authors, and also date. So this is all we need. And so from the original data set, we also, first of all, excluded all retweets. So we thought if we are really going to look at how each author writes and what are the semantics within the text, then we don't really want to pollute that with retweets, because this might be from different authors that they retweet. So we just excluded them. And in the original data, there were also some columns like IDs or link to the tweet, which we also dropped. Yeah, and as you can see here, unsurprisingly, we have most tweets from Donald Trump.
Yep.
So that's 14,000. Obama comes in second, and Clinton third with 5,000 tweets. And below there, you see just a histogram of when these tweets, when most of these tweets were posted. So you can see most of them were in 2016. And other than that, yeah, it's more or less evenly distributed. But of course, from 2018, we don't have as much yet. Right.
Yeah, and we'll go ahead and sort of share this code as well. We'll put it all in a GitHub repo and put it in the link below. So you can check out a little bit on how we used to scrape the tweets and sort of get them to a CSV. So there are a lot of things that you can do with this. And we will discuss a couple of things that you can do with this type of data set. So, one, we can try to classify who's going to be the author of it. And 2, we can try to figure out what are the ways that Barack Obama and Donald Trump tweet or talk distinctively as compared to each other. So one of the things that we start off with, one of the things that we thought would be cool, is to look for things to distinguish tweet authors, right? And we had 2 approaches. So I'll be handling sort of the first approach, and then sort of Mo will finish it up with the sort of, I think, cooler approach. So first, we just wanted to use sort of a naive, very heuristic-based tool for looking for most distinguishing words. So this can be maybe important if you were trying to learn features later on in order to engineer something that would actually classify things. So what I did in this case is I made a little function called getMostIndicative. They went ahead and got a bag of words representation of the full text, made a bag of words representation for each author, and then find that author's relative word usage. So let's say Trump uses the word MAGA, 90% of the time. Of all uses in sort of like the full tweet dictionary. This would be a pretty indicative word of Donald Trump. So if you see MAGA in a tweet, you'd probably think, oh, this is most likely from Trump, and you'll see that below. So I went ahead, I made a dictionary going from index to word, just something that was needed to do here. And I found the most indicative words by going ahead and doing a sort. So I went ahead and I looked for all of the words that this person used in an indicative fashion. So the rate of which, so if you look at number of times Donald Trump used the specific word versus number of times everyone else used the specific word, I took that ratio and I just sorted based on the ratio. The only thing that was somewhat hacky here is you need to make sure and choose words with good enough frequency. So in this case, I went ahead and I did a min-df. So min-df in this case represented, I wanted words that were at least used 100 times. And so we find some cool ones. I mean, the things that kind of make sense. So for example, in the most indicative column, we've got like get covered for Barack Obama, raise the wage, Obama 2012, right? I mean, that kind of makes sense. And I guess if you sort of look at, instead of the most indicative, if you look at sort of the most used, you can see a problem with saying like, hey, let's just go ahead and look at the most used words that Barack Obama used. This might be pretty indicative of Barack Obama. And it's not. Right, you get like HTTP, right? Ooh, I mean, it's not necessarily good. Or president, or even Obama, and other people tweet about Obama quite a lot. So for Hillary Clinton, you've basically got, Hillary Rodham Clinton, you've got FLOTUS, Hillary status, and then of course for Trump, you've got things like Make America Great Again and Crooked, which we can assume where this is applied to. We'll go ahead and dig into this a little bit more, but this can kind of give us a good intuition as to what these authors have been saying and what makes them distinctive as compared to the other ones. Do you guys have anything to note on this one, or?
Well, not really. Of course, so these things like HTTP, they could have been pre-processed out before. So that's always a complicated thing in natural language processing, to set up like a proper pre-processing steps, because it's basically an art form to set up the proper pre-processing steps, because you can do so much stuff. But yeah, we just ended up using the scikit-learn version. Of course, we could have excluded these things like HTTP, but yeah, in this case, we didn't do it.
Yeah. The scikit-learn one does a couple of good things with this. So it tokenizes the words, it puts them all to lowercase, or removes special characters, and it removes stop words. But yeah, it's not Twitter specific for sure. Okay, so I mean, this was kind of cool, but let's do some more interesting stuff. So Mo, if you want to sort of take it away and sort of explain the rationale of, instead of doing this handcrafted feature extraction, sort of some decision tree, or your sort of more advanced feature extraction, and then using the decision tree and then visualization afterwards.
Yeah, definitely. Thanks.
Yeah.
So yeah, in addition to one thing about the pre-processing, we can see in that first cell where dealing with some of the special characters that were present in the data set. I noticed sort of when running the first pass of the feature extraction that there was still some words, for example, like a quotation mark would be removed before the word the, but in other cases a quotation mark wouldn't be removed. And that kind of dealt with, there was different quotation marks with different Unicode codes. And so those were commented out there. So it turned out that maybe it's machine dependent. So I run Windows 10. And now that we're working on CodeLab here, where it's some other server, I'm not sure if maybe the machine interprets the Unicode differently, but that kind of gives you different results based on like which punctuation marks are present. So kind of something interesting to deal with. Maybe that's present when scraping these sort of data sets from things like Twitter, which like lie on big servers. But yeah, something to note. Here we didn't remove the special characters, so that might introduce some sort of bias into the data. So yeah, in the next cell there, there's some basic pre-processing, lower casing, removing the punctuation, and then splitting up like the big list of words into the of each tweet, and returning that into a new series, the process text. And then similar to Nate, I did a count vectorizer to get the word counts. And in terms of generating features, my idea was in the beginning, I picked some of the words that might be indicative into what we think would be some like defining things, like what sort of came up there in terms of like Make America Great Again or FLOTUS. But the corpus is pretty big, so in favor of sort of automating that task, I created like the count vectorizer to get the total word counts for the documents and sorting them. And then in the next cell there, you can see after comma ascending equals false, I grab the first 100 term values. So I'm picking the top 100 most common words outside of the stop words, so just like the sort of unique words, and picking those as the features. So essentially we have 100 features here that are going into the decision tree. And yeah, just a simple one-hot encoding to create the features. Then we can see them all there. So a 0 or 1, depending on whether that word is present in the tweet. You can see the word like join is there on Obama's tweet about climate change. Yeah. So yeah, that gets fed into the decision tree down below. And we picked a decision tree actually because it's probably the easiest to visualize in terms of sort of seeing what is happening within the classifier. And because of that, there's 100 features here, but I picked a min depth of 3, maybe 5 might be acceptable for this purpose. But if you go too deep into the decision tree, you end up with this huge chart that might just be kind of crazy to deal with. So yeah, there's just 3 splits on the decisions there, and then using the entropy criterion for splitting the nodes, and then a nice easy fit with the sklearn API. And there, I kind of grabbed this right off of a Stack Overflow question of, exporting. There's pretty simple method for exporting with PyDot and GraphViz for getting the visualization, which is nice and well documented. So yeah, we can see that here. Pretty clean decision tree. And
okay, walk us through what happens with the decision tree. So we're classifying a tweet.
Yeah, so the first entry there in each box is the word that's sort of the determining criterion on whether to make the split. And then the entropy is the sort of loss metric. That's lots of linear algebra and statistics, math going on under the hood. But basically, like the entropy criterion decides, like, there's a threshold that's hit on whether to split the tree, and then the number of samples and the value sort of. It's a little bit unfortunate. The value term, they don't. I looked through the documentation. I couldn't find much on which value corresponds to which onto which label. So in terms of Clinton, Obama, and Trump.
Yeah. I think the first one's got to be, just from the counts above, first one's got to be Obama, middle one's Trump, and then the last one's Clinton, right?
Yeah, so yeah, just from inferring what the split is, it's somewhat clear.
Yeah.
So we can see sort of what are the determining factors there of the top 100 features. Kind of, Obama's a humble man, but he seems to maybe do a little bit of self-promotion. He was up for re-election, so his name alone in the tweet, and I guess that Trump maybe talking smack about him also adds to that. But that seems to be a determining criterion. And then great, we can obviously know who's saying that in terms of make America great again, and Donald Trump. Kind of easy splits there on the left side.
Yeah.
And then a little bit of self-promotion on the other side for President and Obama.
Right.
And then I think Hillary Clinton one seems to be a little bit maybe more mixed in.
Yeah, where is Hillary sort of located in the bottom here?
Yeah.
She doesn't seem to be super well segmented out.
If you shift over to the right, there's one with 168.00, which is this
is Obama, right? This is all Obama.
Yeah.
So anyway, so the example would be, hey, does the tweet contain Obama or not? If the tweet does not contain Obama, so if it's on this side, then let's ask another question. So if the tweet does contain Obama, okay, it's most likely Obama, and you notice from down here, like we've got 2,800 and blah tweets that Obama wrote that contain Obama, and then 868 that Trump wrote that contain Obama, and then 31 that Hillary wrote that contain Obama. So that seems to be, Obama seems to be a pretty good definer of whether it's Obama or not.
Right.
Yeah. And
but it's nice that just within three nodes, there was pretty decent accuracy in terms of the training. So just these couple of features alone kind of segment the data set pretty clearly.
What was the training accuracy of this?
It looks like I actually didn't print it out there, but I believe on one of the runs, it was getting like between 85 or 90% just from the three features. Yeah.
Wow. Okay. It's easier than you'd think.
Yeah.
And so, is there anything else we could have used other than sort of like bag of words to separate these tweets? I mean,
yeah, maybe like TF-IDF, just different sort of metrics on how popular the given word is. The word is given the tweet, or even like an embedding.
Yeah, right. And we'll be doing some embedding stuff later on with Amadeus. So. Okay.
Yeah, I think that kind of wraps it up.
Sure.
I think the LSTM is next.
Or
Markov model, excuse me.
Just the Markov model, no LSTM stuff.
Yeah.
So yeah, we kind of finished. a section and kind of giving us an intuitive explanation of like how these tweets differ from each other. How does an Obama tweet differ from a Trump tweet, and how does a Trump tweet differ from a Clinton tweet? And this might be interesting, for example, if you've got customer reviews from specific customers and you want to figure out how they differ from each other. What specific words, what specific topics do certain customers focus on versus other customers? And again, I mean, we used a decision tree here. We're not looking to create like a really great model, right? We're not looking to predict, actually predict which tweet belongs to which person. We're mostly using this decision tree to get some intuition as well as describe the features that are important in a very nice visual way. I guess if we were trying to go for something high accuracy, I guess we could, there's a lot of other things that we could do. Most likely just like a random force would probably be a lot better than a decision tree.
Right.
Okay, so some other fun stuff you can do with NLP data sets with words. So what we thought about doing was doing some generative models. So doing a Markov model as well as perhaps doing an LSTM model. So we didn't. Unfortunately, it would take a little too long to go ahead and go over the LSTM model in this one, so we decided to sort of skip it and maybe do it in a later one. But we did do the Markov model. So in this case, sort of a Markov model, the distinguishing fact about this is that, hey, we're going to generate tweets such that we only care about the previous two words. So for example, when we're generating a tweet down here, we generate the word president. And then after we generate the word president, in order to figure out what the next word is going to be, we only really keep in context that we just said the word president. We sort of don't care about the full, whatever happens in these sentences. So for example, sorry to sort of skip to the chase, but if you go ahead and look down here, buy directly from, right, and then CBS Evening News, right? If you kind of separate this sentence into like buy directly, that makes sense. Directly from, that makes sense. From CBS, that makes sense. Into these kind of like bigrams, into these two-word sort of things, it goes ahead and makes sort of like a valid sentence. But you'll see they become super rambly, like buy directly from CBS Evening News. At some point, the fake news or politically motivated ingrates 19,000 respecting our national anthem. Right? It's right. It makes sense locally, but not globally. So anyways, I'll go ahead and sort of show you super quickly on how you can use a Markov model to do this. I went ahead and I imported something called Markovify. So it's just a Python pipt installed package that you can go ahead and install. And it will go ahead and make a Markov model for you, which is super nice. The only thing that you need to do is you need to go ahead and you need to give it the text. So in this case, I just needed to go ahead and separate based on author. So I wanted to figure out what an Obama tweet might look like if we generated it. I went ahead and I took out the new lines and replaced them with periods. So that's all I did, sort of separated the Obama tweets into sort of like one long string of tweets that are all separated by periods. And then finally, I did Markovify on text, which goes ahead and sort of generates a model like I was saying. I'm not sure if we should get into the sort of details on how we get the Markov model, but if you're curious, go ahead, ask a comment or a question down below, and if we get enough, we can go ahead and make sort of like a small video on just Markov models themselves. But anyways, there's a couple of things here. I mean, I already kind of read my favorite tweet, but which was yeah. But right? I mean, you kind of get like some things that sound maybe I'm making this up, but like ever wonder what consensus looks like sounds like something that Obama might have said at one point. So that's Obama's. Trump, right? I already read the very, very funny one. Honored to serve as the capital gains tax, which is somewhat funny. And then enviro-friendly question mark. Like, anyways, and then of course you've got the Clinton tweets. I mean, it makes sense. Keeping our families and communities, hats off to care for 9 million children. And then, unfortunately, expire kind of like ends the tweet. But again, we're lacking global structure and stuff like that. And if we did an LSTM model, it could perhaps capture at least sentence level global structure a little bit better. So I don't know. I don't know if you guys have had any experience sort of trained generative LSTMs or Markov models before?
I mean, it's still pretty impressive just for a Markov model, right? So LSTM is just so much more complex, and I tried some LSTM stuff before, and I mean, it still has issues, right? It's not like it's this beautiful deep learning solves everything, text comes out of it. It still at times looks very similar to what these Markov models show. And I mean, Markov models are just so simple. It's so quick to train these. And I mean, also, this is just a great example of the current state of Python, right? You want to train something like a complex Markov model, you just say import Markovify, and there's like a one-liner that trains the whole model, and then you can just generate it. So it's really straightforward.
It's
actually I tried to build the LSTM, and I kind of made the mistake of initially picking a character-wise memory in terms of like predicting the next character or the next word, and it took several epochs, and training on a GPU too, for a while, just to learn words rather than predict full word to word rather than character to character, which you spend quite a bit of time like learning the representation of. So just kind of a important thing to know when you're training one of these guys, either LSTM or Markov model.
I mean, the character-based LSTMs do well, but you have to have so much data in order to go ahead and get them off the ground. So,
right, and they often get in some sort of loops. So, I mean, they start with some characters, and then these characters repeat themselves. So that can happen sometimes.
Yes.
It's also pretty impressive. Just like, it's one thing to do like the feature extraction and see directly like, okay, the word "Make America Great" again is like that term is popular, but creating, even if they're not fully fully understandable tweets, it's still kind of interesting just to see what these representations are and like what these sort of overlying trends are, even if they're not totally coherent. Kind of very intuitive to sort of read and understand.
It's super cool. I mean, this is the first, like literally the first deep learning model I ever made was a name generator. I can't even remember when I did this, but it was basically using a character-based LSTM, and I got on Kaggle, there's a name data set. And I got this name data set from Kaggle, and I went ahead and I had an LSTM generate names, right? It's sort of like a way of procedurally generating new names based on like specific cultures, I guess. And so anyways, and I literally, back in the day, it was right when TensorFlow models came out, like that repo. And I actually committed it to TensorFlow models and issued a pull request, and they accepted it, right? Well, it's no longer there. You can look back in history and actually find the pull request.
It's in the archives.
It's in the old commits that, I mean, it's these days it's very formal, right? But it's the good old days. Okay. Amadeus, do you want to take it off with the most complex stuff that we did this time?
Well, I mean, technically it's the most complex, but at the level of the code you have to write, it's similar to Markovify, actually. So the last thing, or one thing that we also want to try out was Word2Vec. And so Word2Vec is basically an improved version of the bag of words vectorization that you've seen earlier. So the idea is that if you have a bag of words model, as we've said, you basically take every word that occurs in your data set and you make a column for it. So these vectors can get very large and very sparse. And Word2Vec basically is the idea to solve this problem by forming a more dense representation. And does so by training a two-layer neural network. And there are basically two main versions of how you can accomplish this. One is called continuous bag of words. And in this version, you try to build a neural network that uses context words to predict the target word. So target word just means the word that you're looking at, and the context words are the words that are surrounding the word. And you can have varying window sizes. In this case, it just looks at the two words left and right of the word. And then it tries to predict for the continuous bag of words model the target word. And there's another model called skipgram, and this one uses the target word to predict the context words. So below here, you can see a little representation of how this task looks like. So the target word in this case would be Fox, And you can see this little vector representation. So the yellow dot is supposed to mean that this dimension stands for Fox, and this is active in this vector. And then you go into a hidden layer, and then you map this into a representation of all the context words. And this is, again, just the bag of words representation that you had. And now the idea is that this hidden layer should have much less dimensions than the bag of words model would have. So these are typically 300 is a common way to define these. So just 300 dimensions, which is a lot less than you would typically get with a bag of words. And then if you just let this network train, then it will form a more dense representation of the target word that you have. And of course, the main idea behind this whole approach is that words are defined semantically by the context words, so the words that surround it. That's typically a property that we find in language, and so this technique sort of abuses this. Okay, anyway, so we try to apply this approach to vectorize our words. So again, here we use the scikit-learn count vectorizer to do the pre-processing on the data set. So we exclude stop words for English, we lowercase everything, and I also have a token pattern here to remove any special characters, and also any words that are shorter than 3 characters. So if a tweet just says A or just a very short word, we just remove it because we don't want to have that in our data set. And here you can see what this pre-processing did to the data. So on the left-hand side is the original text, and the right-hand side is the tokens that we have. So in Python, this is just a list, and every entry is the word that we found, and the word that we also think is meaningful for the tweet. All right, then we go to the word-to-vec modeling. For this, we use the library gensim, which is very commonly used for word-to-vec. And similar as with the Markovify stuff, it's very simple to do these things. We just, from gensim models, we import word-to-vec. And the way we computed this was by just create a little dictionary called word-to-vec models, which maps from the author to the word-to-vec model. And there you can just have to enter these sentences parameter, which is from our text tokens. And what we did after that was that we now have 3 word-to-vec models, which all represent the semantics of one of our authors, right? And what we found interesting now was to select certain topics that might be recurring in the tweets from these authors. So health, America, China, women, important, support, LGBT, Trump, Obama, and Clinton. So the idea is that if we find the vector representation of this topic in each of these models, then we can look at similar vectors. So this is also a function that gensim supports. Here you just find a loop that loops over these this function from gensim. You just have to call VW and then similar by word and then the topic. And then you can list the top entries, which are the most similar word vectors to this topic. And we just chose the top 3. And if this word is not represented in the vocabulary, then we just output undefined, which is necessary in some cases, as you can see.
Yes.
So here you see the results. So for the topic health, you just get for every author the 3 most similar ones together with their similarity score. So you see for Hillary Clinton, health is associated with access and affordable. For Donald Trump, it's with private. Choice. And for Obama, it's with affordable care, and care reform. So this all makes sense from what the authors are known for, obviously. And then, we just I'll leave you to judge the other examples. So we have America, which is great, of course. Trump says.
Yes, great.
Clinton also says it's great. And of course, Obama thinks America should be about opportunity for all and education.
That's right.
We have China. Trump thinks China is laughing at us, maybe.
Yeah, I find this very strange to me.
Killing is a bit harsh.
Yeah. Anyways, I'd be curious to look at some of the tweets that Trump actually tweets out about China.
Exactly. And of course, we have to keep in mind that this is not this is also not perfectly fair to the author. So this is not like an objectively similar thing. It's just something that we find in the data. But it can, of course, be that this is not actually what the author meant, and it just seems like it if we do it like this with this modeling.
Yeah.
Okay, we have women. Clinton thinks women should vote. It's a good start.
It's a very good start.
Trump isn't so bad in terms of women. Also says freedom, honored. Okay, and then
it's interesting. Yeah, I think this might have to do with abortion. I'm not sure. Sort of maybe just adults and choices and stuff like that. Anyway.
I see. Yeah, that makes sense. Okay, then we tried important. Hillary Clinton, justice is important. Right and matter. Well, Donald Trump, results are important.
Results.
And talent.
Talent. Mm-hmm. Mm-hmm.
And this is pretty genius for Obama. Facts are important.
This. Yeah, that's so awesome.
Yeah. Lining up is awesome.
Yeah. Okay, for Clinton, support. Clinton wants to support women. Justice. For Trump, MAGA, of course.
Which make America great again. Sorry for people that aren't familiar with it.
Right.
Yeah. This is.
LGBT is pretty great. So for Clinton, we are fighting and women and voting, and for Trump, it's undefined. So it actually was not often enough in his tweet data to
his 14,000 tweets.
I don't have enough data on this. I cannot possibly use this. So it's just undefined. And for Obama, it's again important
story. Yeah. This one's interesting too.
Do you want to actually continue with this?
Oh no! You're doing great. I'm sorry for interrupting.
No. Go ahead.
Oh, I think it's very funny. So if you look at sort of like the topics on Trump, Obama, and Clinton, like they're all talking about each other except for one relationship. It looks like Barack Obama has better things to do than to talk about Trump, which is kind of like the funny thing.
This might have actually been like a strict rule that he has. I will not use the word Trump ever.
It could be. Right. It actually could be. Right. I think the other interesting thing is, of course, like the Donald Trump talking about Clinton, is crooked, comes up with the number one word, right? And this was also very intentional for Trump. He makes these like derogatory nicknames and he sticks with them.
Exactly.
So
of course you can do a lot more cool stuff with Word2Vec. So usually you would use these dense representations to put it in a machine learning model so that the model fitting just gets easier and it doesn't have to deal with these sparse matrices. But this is also one neat function that you get, this similar by word function, and you can have a lot of fun with it. Yeah.
I just love all of this has been really good for exploratory data analysis on words, right? On any sort of text-based documents. Again, if you're looking for customer reviews and stuff like that, and you have multiple customers, perhaps it might be something really good to go ahead and look at bad, right? And look at similarity word scores that were similar to bad or terrible or like frustrating or like these types of things to figure out maybe what words they use commonly with negative or positive things to figure out what's good or bad about your product specifically. Yeah. I enjoyed this. It's very fun, but I just want to state the point. It's also useful, right? This is not. We chose a very interesting topic, so it's it might seem somewhat whimsical, but a lot of these techniques can be really useful for exploratory data analysis. Sorry about that. On data sets with text. So.
Right. So one last thing I want to mention. So in a previous version of this, we used actually the library Spacey for text preprocessing. So with scikit-learn, you can get quick results, but Spacey is a bit more powerful. And so for this, if you just have tweets, which are obviously very short, the scikit-learn vectorizer does well enough, I would say. But if you're dealing with longer texts and more semantically complex texts, I can definitely say that the Spacey preprocessor is worth a shot. So it gives you some more fine-grained preprocessing, so you can find word stems easily, and you can have functions like remove all URLs and these things. So yeah, but obviously it takes a bit longer to pre-process it, and we didn't want to overload our collaboratory kernel with this, so we just use scikit-learn. But I can definitely say so. Spacey is worth it if you're dealing with longer texts.
Yeah. Okay. So I mean that brings us to the conclusion. I hope this was really fun for people watching. It was fun for us doing it. I promise you, except for the Jupyter Lab and CoLab stuff. I think that was the only part that wasn't fun for us. But we had a couple of different ideas in order to do more of this type of stuff. Again, sort of exploratory data analysis on text data. So I mean, of course, an LSTM generative model. So using deep learning in order to make the sort of like Markov model above. So we could use LDA in order to. Oh no. Whew. Okay, LDA in order to extract the topics of the tweets. So instead of, we had really good intuition as to what the topics of these tweets would be, like women, China, America, these types of things. But if you had less intuition, you could go ahead and use a model to go ahead and extract topic. Well, to give you ideas of what the topics might be. Sentiment analysis is something that we could have totally done here, right? And I'm sure there would be very interesting things on sentiment analysis. Very interesting things, right?
Yeah, I would guess Trump and Hillary have more variance in the sentiment.
Yes, I would
Obama
guess.
is more controlled, probably.
That's what I'd think. Yeah, and there would be some really cool visualizations of this we could do as well. But there's only so much time. Who thought of this? The tweet responder bot?
Oh, I just randomly mentioned it, which would be fun. I mean, right now we just we didn't look at responses, right? It was just tweets, but we could also train about that response to something. This would, from a machine learning perspective, this would just be like a different goal.
Yeah.
See what causes the most stir, start some fires.
Yeah. And that's also like if we wanted to use the data on likes and retweets and sort of get into sort of perhaps like a Twitter optimizing type thing, like what words and stuff like that might cause you to get more likes and retweets. We could have gotten into some causal inference, and plus we could have just had much more to do.
Exactly. The likes just give you more fine-grained data, right? Yeah. Right now, just every tweet is one sample in our data. But if we have a tweet that has like a lot more likes than the other tweets, we should probably weight it higher in some goals. So this is very useful information that we could have also used.
Yeah. And this is literally only stuff that would involve sort of fun / exploratory data analysis type projects. There's a ton of stuff that we could have done above and beyond this if we were actually interested in making some impacts, right? So I don't know. Do you guys have any other parting words, any other concluding remarks for aspiring data scientists?
Well, as you can see from the conclusion, there's always a lot more to do than you can do.
Yes.
But I mean, with these kinds of things, so this is a great example of how you can learn data science, I think, because it's just so fun to go through the data, as you can see there. So I think data sets like these are great to learn something, and they're also very complex. I mean, you can probably use any machine learning technique except the ones dealing with images and apply to this data set. And probably like 70% of all the machine learning knowledge could be trained on this data set. So I can recommend data sets like these to train.
You could even use 1D convolutions for images. Yeah, but I mean, as even a aspiring data scientist myself, like you guys said, just working on these types of projects is grabbing data from Kaggle, collaborating especially is worth a lot, even like in comparison to sitting in on lectures and stuff. Lectures digging into the code and learning how to make these representations and figuring out what's important to sort of see and visualize and understand is definitely a valuable tool and skill set to have.
Yeah, 100%. I think that this is a lot of people go out there and they just basically learn about the models without actually applying them to some real messy-ish data. And I think that's sort of like what you're doing normally on a day-to-day basis.
Yeah.
Right? Most of data science is dealing with data, not with models. So, okay. Okay, well, once again, I just want to say, like, give a massive thanks to Amadeus and give a massive thanks to Mo for helping me out do this. I couldn't have done it without you guys, and you guys are really sort of helping out sort of the data science community, and thanks a ton there. And then finally,
thanks.
Yeah, of course.
Yeah, thanks for putting it together. You know, it's fun to do and fun to help contribute on.
Definitely, and thanks for making your videos. Obviously, I'm already giving it out to junior data scientists. So if you're gonna get practical, you want to have practical fast, I think this is really a great channel and great videos for this.
Thank you. So as always, I've got to say it. Please stay tuned for more. Ask any comments or questions below. We'd happily get back to you. We're going to post the code on GitHub and stuff like that. And if you haven't already, please subscribe. Thanks. And this was the second episode of Data Talks. Woo!